We started recording, so I'm going to start talking.
Sure.
I'm Dan Nagy. I am a consultant. And he's also go, oh, hi Dan.
Hi Dan.
Yeah, and I'm legally required to say that, so I've now satisfied my contractual obligation to call myself a consultant. I came to Cali probably, 10 months ago, and I've been working with them getting some of their stuff together. They had a huge, the title of the talk, Nick and I do, by the way, Nick, Moline, and myself are co-presenting. The way this is going to get laid out is I'm going to go first. I'm going to do kind of the application layer stuff. Nick is going to go depth first on a few things. We are collectively Purple Squirrel 1 and 2. Doesn't matter which one is which. So we, Callie and Justia, many of us have a lot of infrastructure out in the cloud. Today we're going to be talking a little bit about the redundancy and latency. I'm going to talk a little bit about walking through the front door of a new organization as well and what you encounter when something like that happens. But I don't know why we're talking about this stuff, right? Because the cloud is magic. I mean, you just put it in the cloud and everything magically works. There's no redundancy, no latency. Everything is just peachy keen all the time. And there's a magic cloud. It's the most magical cloud I could find. So, like I said, about 10 months ago, I walked through the front door of Cali. It was really scary. And you start looking at different stuff when you get in there. So, and it wasn't that Cali was in that bad a shape when I walked through it, but you could tell that it's a small organization and they hadn't had a whole bunch of time to devote to stuff. So stuff was set up properly. It just hadn't. It's like an untended garden. It just hadn't been looked at a lot. And Elmer had actually proposed an alternative title for this talk, which is Dan Cleans Up After Elmer. But it really wasn't that bad. It was just a lot going on. I mean, it's a busy organization. So, I mean, the first thing you do, and this is my first experience doing that kind of thing, was you walk through the door and you immediately freak out because you start looking at other people's stuff and you really want to start, cleaning stuff up. But you realize pretty quick that it's more like an archaeological dig, right? You're going through and you're picking apart stuff that is, it has documentation, but it's old. It's been in place for a long time. And when you're touching stuff like that, you have a choice of tools to use. And the tool you use when you're doing stuff like that is the little fine brush that you use to dust off something really, really important. You don't use the backhoe, because if you use the backhoe, those guys show up, because eventually you're going to hit something that detonates. So the first thing you do is you just take a deep breath and you calm down, and then you get nervous again, and then you really calm down, right? And then I remembered this, right? So that's Bruce Lee, and he taught martial arts and he studied martial arts, but he always considered himself to the day that he died to be a student, and he studied multiple martial arts. And whenever he would go learn something new or walk through the door of a new experience, one of the things he would say was, I empty my cup. And that doesn't mean forget everything you ever learned about, because you have a world of experience behind you to help you along. What that means is just be open to new things. I mean, the cup is useful when it's most empty. That way you can understand. So the difference between Cali and the organization I worked for before, it's the LII, was not night and day, but it was different enough to be a little scary. So the first thing I started doing when I got there was I started looking at the scope. I mean, where are the edges of the organization? What does the shape of the org look like? What is it actually doing? So now we're getting to the meat and potatoes of the cloud redundancy stuff. So one of the first things that we did, they were running Google Analytics. So you start looking for metrics, right? So there are two ways to look at the metrics. And there were two tools that I put in AWS Stats, and they already had Google Analytics. Google Analytics, the way Google Analytics works, I'm sure everybody's been looking at it, is you bug the pages you want to keep track of. It's a really nice interface. It's you get real-time, just about real-time data back from it, but you're only looking at the pages that you bug with this little bit of code. Different package, AWS Stats, has been around for years, and what it does is it trolls the logs. The difference with AWS Stats is that it's very resource intensive, so it's more like a reporting tool than an analytical tool. So at the end of the night, it generates a report about everything that happened that day. But since it watches the logs, it picks up everything that happens with all the instances that, in this case, Apache instances. It can be made to look at any log, but in this case, we're using it to look at Apache. And the thing about AWS Stats, the trick with AWS Stats is that if you're running stuff in a distributed architecture, you have to have some kind of centralized logging facility so you control the logs at the end of the day. And this is just a shot of the AWS stats screen. I think I took it just a couple days ago, and it's much more extensive than this. But typically what we're looking at, we look at how much load do we have, over time. Cali has a pretty predictable load cycle. The end of the semester, the load on the websites go up because a lot of people run lessons, and then it kind of tails off, especially during the summer and stuff. So, but the one thing that collecting the metrics do is they give you situational awareness, right, about what's going on. And I went into it having some preconceived notions about what I should be seeing in the data. And one of the things I saw when I put up AWS Stats online was the exit page for Cali. At the top of the list, where everybody left the Cali site, was a login page. And I came to him and I said, fuck, we got a problem, because everybody's coming and then they're immediately just going away. And he patted me on and said, no, that happens. They're getting to the site wrong. They get to the site and they realize they don't have their credentials, so they go away and they go find their credentials and come back. So at some point, you start building your awareness of, well, that's what the data says, and you look at it as maybe I'm seeing this for the first time, or do they know this is happening? Yeah, they knew it was happening. But it was nice for me to know that it was happening and seeing it my own way. The other thing that I did when I got there was we started to monitor stuff. And this is, Nagy is a really popular piece of monitoring software. And the nice thing about, Nagy is mainly there to tell you when you've got a problem. Everything is nice and green. When stuff gets a little iffy, it gets yellow. When stuff is on fire, it goes red. That's when you start paying attention. But really what it also does is you start noticing trends, right? And so like when we make backups of the MySQL database, everything slows down a little bit. But you get used to seeing that pop every night, at around midnight, that this is going off. And if you don't see it, something in the back of your head says, well, I should have probably did the backups knock off. And then there's another job that checks the next morning, which tells me if the backups went off or not. But the other thing you can do is you can bend it to your will a little bit, where you can actually write tests for MySQL or anything else you want to kind of test if it's creaking at the seams and how well it's working. So you can test stuff like cache hit rate in MySQL, so that you know when you're starting to saturate the resources you already have available to you. And as you start seeing it trend more and more over time, maybe a piece of code got pushed that's causing more stress on your back end. Maybe you're getting more cycles. Maybe you're just getting more patrons coming in, and you need to start thinking about doing something with your infrastructure. So not only does it monitor and tell you when there's trouble, but it will also monitor and tell you when you start needing to think about doing something else with your resources, maybe adding more resources, structuring them a little different. And then the other thing, another way that I was collecting metrics is page load performance. Now, and the thing I started looking at when I was looking at the Cali stuff is I would pull the pages up and look at them. There's a lot of tools out there you can use, and there's two main things, just real quick and dirty, that I was looking at when I was looking at page load performance. The first thing is the time to first byte. How fast does it take for when my browser hits that, contacts the Apache server, in this case Apache, to give me the first byte of data? And that pretty much what my reasoning was that told me how well the actual infrastructure is working, not the site itself, not the page itself, but how well the actual infrastructure was working. And then the other metric I would look at was the total time for the page load. So the time the page began to load and the time the page ended to load. And if I got the time to first byte down pretty quick, that means that Apache was working well. If the page took forever to load, that could be an infrastructure problem, but very likely it was something else. It was either a really heavy page, trying to do too much on the page, there's something going on with the back end that's causing the page to load slow. But the infrastructure itself is relatively sound. I mean, we got a snapper response at first, but then something happened over the course of the page load that caused the page to load slow. So you start to try and track down why you're getting iffy page load performance. But again, you're just collecting metrics at this point to see where you're creaking at the seams. So just about the time everybody started moving onto the cloud, everybody also started moving to content management systems. And the one thing you realize about CMS is, in this case, I think we're talking about Drupal here. In the beginning we had flat HTML, and it was rocking fast, and there was much rejoicing. And then CMSs came, and all of a sudden, performance started to tank. I mean, they weren't exactly the fastest things in the world, but they were never meant to be. They were meant to help you manage your content and put it out there, and the ease of putting up content. They're also not particularly optimized to be development platforms. So you have that issue as well. But we're just really talking about the CMSs. So you have the ease versus speed things with content management systems, and then you really start to need to optimize once you get that kind of stuff. I mean, before, one web server was enough. Maybe not for redundancy, but for speed and service of your patrons, one web server was enough. You're serving flat HTML. You stick a content management system in front of it, all of a sudden you wind up needing several more resources to serve your patrons, but it becomes easier to get the content up. So you start looking at tools, and now we're all living out in the cloud here, and in this case we're living in the Amazon cloud. So you start looking at shiny tools. And something that Wise Man once told me was, just because you can does not mean that you should. Now that's not a Klingon torture device, that is actually an Apple core. And that was my first experience with, and if you give this to your 7-year-old son, and you tell him to core some apples for you, you will get way more apples because it is extremely easy to use. You will get way more cored apples and peeled apples than you will ever possibly use. And especially if you ignore the kid when he's doing it because he's having fun, he's quiet. That's also an example, and I don't know the 2 steps first, but somebody pointed me at this, and this is also the reason, just because you can doesn't mean you should. This is somebody showed me this at lunch today, or told me this at lunch today, this is the Arnold Schwarzenegger programming language. Right? So again, just because we can doesn't mean that we should. So some of the simplest tools, and so usually right out of the gate, there's one of the tools that we can, several different types of tools you start looking at right away, are caches, content delivery networks, CDNs, and distributed backends. Right? Cache is usually the first because usually the stuff that everybody lights on immediately. And we got 2 different kinds of caches. You got a static page cache, and there's a program out there called Boost. And then you have the kind of the HTTP accelerator kind of, and not really cache, but we'll call them cache, called like Varnish. And the way that the static page cache like Boost works is they sit on the individual, we'll call them instances, old name is servers, and they'll sift through your stuff, and or a patron will come in and touch one of your web pages on, say, Drupal. That page is then built as the person looks at it. What Boost does is it says, okay, this page just rendered, I'm going to take this page and cache it as a file out on the file system. And then you have a set of rewrite rules that Apache is obeying. And the next time a different patron comes in on the same patron, it looks to see if that file exists. And if it exists, it serves up that file back to the patron. So it doesn't even touch the CMS and touches very little of the back end to do it. So you're basically then serving flat HTML. That can serve 2 purposes. The first thing that it serves is, the first purpose that it serves is it speeds stuff up. Right? Now you are serving flat HTML. You're not going back to the CMS to generate the page every time. The second purpose that it serves is it does add a bit of redundancy. Now, really popular pages get cached, right? So the stuff people look at the most is sitting there as generally speaking, flat HTML. So if for some reason your backend goes away, your backend database goes away, the page will likely still serve, or at least part of it will still serve. So you're getting both redundancy and latency reduction using a static page cache like Boost. The problem that you have is if you have a distributed environment, and we'll talk about that in a minute, if you have more than one app server serving up stuff, so you need Boost on every single app server you have serving. So it may not be the most, so you got to set it up 3 times unless you're going to replicate it. The other thing about Boost is, you got to remember about static page caches, is that you eventually have to expire the cache at some point, and you get stale data in there. So if you change something on the back end, if you add a new content, but what's in the CMS is not what is sitting on the disk, you could actually serve up some stale content. It'll serve up quick, but it'll be stale. The HTTP accelerators work a little bit, they sit in front of everything else. So all the traffic comes through these accelerators, Varnish, and it works somewhat similar to the way Boost does in that it caches things. It uses a lot more memory caching than Boost does. Boost writes a lot of stuff to the disk, Varnish doesn't. And the traffic never makes it to the web server, right? It never makes it to the back-end app servers. That if you have pages that are served a lot, high-hit pages, Varnish will cache them, and then it will never actually even get passed through to your back-end content management system nodes. The newspapers, media uses a lot of varnish. New York Times uses it perpetually, and they've really gotten good because they have to be very timely, and they've really gotten good at tweaking their algorithm for getting fresh content up. So as the news stories change, they've figured out how to make the varnish refresh very, very quickly.
Are these tools free?
I'm not sure about Varnish Boosted.
Yeah, Varnish
Varnish is good. So then one of the other tools that was on that one slide was content delivery networks. So who could tell me the name of this guy? You remember the name of this guy?
Mr. McFeely.
Mr. McFeely. I thought that was a very creepy name for a guy in a kid's show. All right. So there's a couple different flavors of content delivery networks. The Amazon has their own. It's called Amazon CloudFront, and then you can there's kind of like your own little homegrown proxy thing. And so the way content delivery networks work is you take content that you think is going to be really popular, and you stash it somewhere else on maybe a little higher performance system. Amazon works a little differently because Amazon is actually geographically distributed. So if you're serving up things like media files, like big movies and stuff, when somebody goes to your website and clicks on it, it's not coming off of your instance. It's coming off of somewhere in the Amazon cloud, but it's actually coming off a place geographically closer to where that person is sitting in front of their browser. So if you have, and I mean this may be really relevant, and it's like East Coast, West Coast. So if you're looking at a video file and I'm in we're in the East Coast side of Amazon, so that's where Callie's server sits. So if I had the video file sitting there, it would come off of one of their instances only on the East Coast. But if I stick it out in the Amazon CloudFront, and you're sitting out in Mountain View, and you click on it, it will come from one of the West Coast servers. The trick about Amazon CloudFront is you have to be so high for it to be effective. You have to have so much traffic for it to actually cache the file properly and keep it persistent. So if you're getting infrequent visits of a particular resource, Amazon CloudFront is not the most effective way to do it because it will decache it, because I mean you're sharing this with everybody else as well. I mean it's kind of a group resource. So and it takes a while to instantiate out to wherever you're at. So if you put up a video file and it's really popular for a while, it goes viral, then it works great. As the traffic drops off, it gets less and less efficient to use a content delivery network. So it gets a little iffy if you don't have a high traffic website, whether it's actually worth it or not. And the only way to detect that is to run your own metrics on it. I'm not sure that there is any algorithm that lets you figure out how many times the file has to be hit before it becomes effective for you to serve it. You just have to try it yourself. And the other thing, and the way Callie is doing stuff is like the homegrown proxy. So the way the homegrown stuff works is so we have an Apache server that sits there and it serves up Drupal. And then sitting off on another box, we have a Lighty server, right? It's a lightweight, high-speed, very simplistic web server. And that's where a lot of the graphics and stuff sit. And what will happen is you'll come into the front door of Apache. Apache will look at a set of rules, a set of rewrite rules. It'll say, oh, this file exists. Now obey these proxy rules and go over here and get it and deliver it to this person. And because it's a relatively large file sitting on a relatively high performance server, it serves up a little bit quicker, and you're also getting some redundancy. It makes it a little more difficult to keep track of where you have everything, and you have to write the rewrite rules properly. But it actually will serve up stuff a little quicker than if you had it on the actual app server doing all the work. And that would be particularly the bigger the file, the more bang for the buck you get out of something like that. And then we move away from the front end of stuff and into the back end of stuff, the way the data sits in the back. And Nick will talk more about this kind of stuff. But we have database solutions. So you have MySQL can be distributed or configured in certain number of ways. You have the standalone box, not a lot of redundancy, really doesn't scale. You can build a MySQL cluster. We can do that. So you can build a MySQL cluster, which it basically works like anything else. It just shares data through a whole series of MySQL servers. One of them elects itself as the master and then tells the other ones what to do. One can drop off, come back in, load is balanced between all the MySQL clusters. And then the more simplistic way to do things is the master-slave MySQL setup, which most people do. It gets you a lot of redundancy. Stuff writes to the master is virtually a couple of milliseconds written to the slave. If you got to do heavy queries, make backups, do whatever, you can do all that stuff on the slave so that you're not impacting the master where what your production website is looking at. So you do all your maintenance, you do all your queries, you do all your backups out of the slave. It doesn't get you any kind of fat finger protection. So if you drop a database, it's going to drop on the slave just as fast. So you can't quickly go back and say, oh, well, you can't. It's not an undo button. But it does add. But the master slave stuff is something that's pretty common. And if you're not doing it, I highly recommend you do it just to make sure. And you'll see it. The slave will drop out sometimes when it gets really, really heavy. But it comes right back. And it used to be a lot worse to get the master slave stuff synced. It's a lot easier to do now. They've really gotten better. And then the other way you can do stuff, and Nick is going to talk more about this, is the Amazon RDS. Amazon has its own relational database service that it can sell you. Nick will talk about it's more cost effective. It is actually distributed. It can be auto scaling. They handle the backups for you, and it does act a lot like MySQL. So if you're familiar with stuff like MySQL, this is not that hard of this is not that big of a leap to do. And then I think this is one last thing to talk about real quick because Nick's got to have time, is load balancers. And there's a couple different flavors of the load balancers as well. There's the static and the dynamic. Static load balancer, you have like a director and you have a series of app servers under it, and all the director really does is, using an algorithm, distribute traffic amongst all the other nodes you have under it. And in the static model, you just have a set number of nodes underneath the director. In a dynamic model, based on some trigger, it will build out more nodes for you in as close to real time as it can to satisfy traffic demand. At Cali, what we do is we have a load balancer. It's not an elastic load balancer. You run 3 nodes all the time. For some reason, Elmer discovered that odd numbers get better performance. It has trouble with even numbers. And then when lesson time runs up and the semester exam time comes up, we rev up we rev up 2 more nodes in the back. And that keeps expense down as well. Only running the 3 nodes in the load balancer initially, and then revving up during the thing. And Nick will talk a little bit more about that. And Amazon has it's called the Elastic Load Balancer, and you can actually build one out Amazon build. It's not that hard to do. It's relatively easy. And I think I'm gonna be done. One of my final thoughts is my favorite one. So just watch what you do. And playing with the tools is fun, but it's not magic. Nick, you want me to just send it over to you?
Yeah. Hello, is this working? Good, okay. Hi, my name is Nick. I'm a senior software engineer at Justia.com. We do a lot of free legal information projects. I also manage our cloud environment at Justia, so I spend a lot of time fighting with trying to make the cloud work. So if any of you have ever decided to take the project into the cloud, especially Amazon's cloud, you probably have had a situation with a conversation that kind of goes like this. We need a redundant system. The cloud, I heard that makes it easy. Perfect. Let's get IT to make that happen. Next order of business. Later that week, your IT person down there trying to make things work in the cloud. Damn it, why doesn't this work? Shouldn't the cloud make this easy? I was thinking about what it's like to spend your first day, when you first come into the cloud, and you first try to make things work and make things easy. And I thought of this video clip here that will basically describe somebody's first day in the cloud perfectly.
Okay. I'm just gonna come right out. I have no idea what's going on or what this place is at all.
Hi! I am Princess Unikitty, and I
no signs or anything. How does anyone know what not to do?
Here in Cloud Cuckoo Land, there are no rules. There's no government, no babysitters, no bedtimes, no frowny faces, no bushy mustaches, and no negativity of any kind.
You just said the word no like 1,000 times.
And there's also no consistency.
I hate this place.
Any idea is a good idea, except the not happy ones. Those you push down deep inside where you'll never, ever, ever, ever find them.
I really think that scene in that movie was written by a developer who's had to move things into the cloud. Think about it. It's got the cloud. It's got the engineer who's spending his first time in the cloud. That's Emmett. It's got the cloud evangelist who's telling you that the cloud is great and nothing is ever wrong there. And if anything is, just suppress it. Just pretend it isn't bad. And then it's got a couple of jaded engineers who have spent time in the cloud, realize it's not consistent at all, and then just simply mention how much they hate this place. So there's a lot of complications when you try to add redundancy to the cloud. Frankly, though, there's actually a lot of complications if you try to add redundancy to anything. There's some ways the cloud makes it easier, some ways the cloud makes it actually harder. And then some things that the cloud was harder to begin with, they eventually make easier for you. So that's what I want to kind of cover on here. But first, let's just go over some complications when you're trying to add redundancy to something. Database replication and port over. He mentioned trying to set up a MySQL cluster or setting up master-slave. It's really hard to get something up, especially if you want it to automatically scale. If you want to have multiple slaves and more slaves depending on your situation, it's hard to start up a new slave and join it into the replication cluster. You need to have up to a minute backup, and then you need to copy things over, and you need to know exactly what point your backup's from to the second, or actually to the query, not to the second, because there can be multiple queries in a second, and then set things up. Load balancing app servers can be somewhat difficult, and I'll express some of the terrible things that have happened to me trying to do load balancing. Trying to do search, things like using Apache Solr or Sphinx or something like that. If you need to scale it out and run multiple Solr nodes, it's real pain in the butt. Caching servers, coming up with a caching system. How do you deal with it if you're using things like memcache and you're using external cache servers? What do you deal with it? How do you deal with a single node failure? And finally, shared file systems. If you're running multiple app servers and you in any way need to be able to read and write files, then you need some sort of shared file system. And that almost always introduces a single point of failure that when it fails takes everything down. So how does the cloud make some of this stuff easier? Well, it's easy to replace damaged hardware. Right? It's the cloud, everything's virtual. All right, if a server's failed, crashes, or you accidentally delete the root file system, you can just spin up another one and you kill that one and that server's dead and gone and you don't care about that one anymore. You've got a brand new one and it's pretty and clean, It's easy to test software changes with temporary servers. You're going to make massive changes. You just spin up a copy of your environment in seconds or minutes, and you have a complete copy. And you can make changes, and it's completely it's the exact same environment, but on a completely isolated system. Bless you. It's easy to test how things like operating system upgrades are going to affect your system. Just make a copy of your environment with the new operating system or the new version of the operating system and see what breaks. It's easy to upgrade hardware. If you have your stuff running on a M1 large instance in Amazon's cloud and you realize that is not enough, you can change it to an M1 XL and have everything else be exactly the same in minutes. But how does it make it harder? it's hard to predict network proximity in the cloud. You know, when you're working in a cage and you have physical servers, odds are they're right next to each other or within a few feet of each other. And if you want really super fast connection, you can even put a separate NIC card in there and have an isolated network connection between them and have it be really, really fast. All right? In the cloud, especially if you do multi-AZ, which you should, and move things in multiple availability zones, you know, two servers might have more latency than two other servers. So you have an app server and you have a database server, and you have two app servers and one database server, and you said this server is really, really fast to the app server, and this server is not, because they could be in completely different buildings, you know, and you have no way of knowing, because when you launch a server, you say, here's your server, but you don't know where that server is. Persistence is somewhat hard. It's gotten a lot easier, I'm going to get to that, but if you have a server come up, you realize you need to make a tweak to Apache, then you go restart the server and you realize that the new relaunched server is back the way your server was before you made that change, right? So, your root file system is typically not persistent. So any changes you make outside of, volumes where you've specifically said it, this is the backed up file system, those changes are easily lost. Amazon's been known, quite infamously, for having entire zones fail. So if you put everything in one availability zone because it makes you super fast, and then the entire availability zone fails, and your entire application is down. And now you say, well, you should put it in multiple availability zones, but then that makes it slower. So you end up with these kind of annoyances that are things that you don't even have to think about in a physical network, but you do have to think about when you're dealing with the cloud. So we got this thing going, me and Amazon. It's a love-hate relationship, where basically I will spend hours and hours and hours trying to figure out something goes on. And then something happens as soon as Nick finds a solution to a problem. In the early days of EC2, there was a problem that you had only ephemeral storage. Every time you launched the server, it's completely empty. If you relaunch that server, everything that was on that server is gone. So if you had a large set of files that you needed to make sure was on your app server when you booted up, you had to have a tarball. You had to be consistently making tarball backups of everything, and every time you launched the server, taking the most recent tarball. Database servers were even worse. You were periodically running MySQL dump, and saving the SQL file. And then if you have to restart the database server, you take that SQL dump file and you run an import when the thing first launched, which is slow and tedious. But and coming up with a system to do this automatically so that if you have to relaunch your server, it was a real pain, But we finally had a system that was working. We were making MySQL dumps regularly. We had masters and slave servers. The master server would do the MySQL dump once a day, and the slave servers would do the MySQL dump every hour. So that, if you needed to replace a slave, you just use a MySQL dump from the master, and if you need to replace the master, you take one of the SQL dumps from the slave because it's more up to date. And it worked pretty well. It wasn't a perfect solution, but it worked pretty well. And then I get this email from Amazon when I'm on vacation in Vegas. It says, Amazon Elastic Block Store for Amazon EC2 now available. This was August 21st, 2008. EBS is fantastic. If you use the cloud before EBS, EBS is your grand savior of EC2. It's basically you create a virtual hard drive which you can attach to a server, and if you relaunch the server, that's okay. The hard drive's still there. You can go attach it to another server in a second, and you can make whole drive backups just by creating a snapshot. It's a great solution. It's so much better than my homegrown solution that I was dealing with, right? But, it only happens as soon as I finally got a solution that's working.
They're sitting back watching you and say, oh, Nick figured it out. This is what we need to do now.
Yeah, exactly. So then, all right, so now we finally get a solution where we're running with master-slave database server, making automatic snapshots of the EBS volume on the master every hour. Those snapshots, every time we make a snapshot, we run a query on the master to figure out the master log position. or the bin log position, save that in a file, make the snapshot, download that snapshot, and then a new server boots up. It uses that snapshot to create its EBS volume, spins it up, runs a MySQL query, connect to the master. We have replicating servers, database servers. It actually works. Still not a perfect solution because we're only making those snapshots of the master every few hours because the snapshot locks the master for a minute, right? Problem then is, you spin up a new slave and it's 4 hours out of date, and you have to wait for the MySQL to replicate every query that's happened in the last 4 hours. It worked. It's a great solution. We even still have some stuff running on this that we haven't moved over. But then we get this email. Announcing Amazon Relational Database Service. RDS, again, RDS is the purple squirrel of database servers. It should not be possible for it to exist, yet it does, and it is amazing. RDS has some features. I'm going to circle back to them in a bit because I want to cover it as a completely separate slide. But I'll tell you, if you're in the cloud and you're working with database server, you need a database server, don't roll your own system, please. Just don't. It's not worth it. It's not worth the time, and you'll never get it as perfect as Amazon will. So, got a lot of links. All right. Okay, so you got multiple app servers. Dan touched on this. You got multiple app servers. You need some sort of load balancer in front of them. Again, in the early days, there was no such thing as the elastic load balancer he was talking about. You would take a M1 small instance and you would run, HA proxy on it, which is a relatively lightweight front-end proxying system that distributes load between different things. It works pretty well, has some issues. Basically, every time we launched a new app server, we had that app server SSH to the load balancer, edit the config file, add itself to the config file, and tell HA proxy to restart. And anytime you would shut down a load balancer, it would do the same thing. It would SSH to the load balancer, it would edit the config file, remove itself from the config file, and restart HA proxy. The problem comes is, what if you have an unplanned shutdown of an app server, like an app server failed? Well, it doesn't do that SSH command. So you get to, your load balancer still has this thing. Now, it doesn't serve any traffic to it because it's dead, right? It's smart enough to know, hey, this is dead. I'm not going to send traffic to this dead app server. But a few days later, Amazon might reuse the IP address of that app server for somebody else, not you. And suddenly, if you have 4 app servers in your HA proxy config, and 1/4 of your traffic is suddenly going to a website selling thread. That's what happened to us. Fortunately, it was not a website selling pornography or something like that, which would have been, I probably would have been fired. But, again, HA proxy sort of kind of works, but you got to be really careful with it. You have to make sure you've got it configured right. Also, because it was literally SSHing to a server, editing a text file, and restarting things, what if 2 app servers launch at the exact same time, and they both try to add themselves at the exact same moment? You end up with a config file that is missing one of them. So you've got an app server running, and it's like, man, this app server is running solid. It's like got no CPU load on it. Well, it turns out that's because it's doing nothing. So we finally get, we've got things rigged up. We write scripts that automatically config, check the current list of servers in the array and rewrite the server so that the load balancer is now reconfiguring itself. And we get this email. Introducing monitoring, auto-scaling, and elastic load balancing for Amazon EC2. Amazon adds this elastic load balancer feature. You make an API call to add something to it. It's automatically redundant. One thing I didn't mention before is M1 small instances fail. So if your load balancer fails, it doesn't matter how many app servers you're running, it's dead. The whole site's dead. Elastic load balancer is automatically redundant. They run your load balancer on multiple servers. It's actually cheaper than running an M1 small instance, believe it or not. Their cost on a firstly booted elastic load balancer is less than running one M1 small. Because they're not just running yours, they're running a dozen of them, right, or hundreds. So they're actually running lots of stuff on a single instance, and you actually get, they pass that savings on to you. So it's a great system. It costs less, it works better. If a server goes down, they know that you've terminated the server, or that the server terminated itself, and they remove it from your config for you, because there's no point in having it point to something that doesn't exist. And so you don't end up with a situation where your website's suddenly selling thread. Caching servers. Admittedly, this is actually the pretty easy one. You try to spin up memcache servers or write a server, something like that, where you have caching. That's pretty easy. But if you're running multiple cache nodes, if you're running 6, 7 memcache nodes, and you've got your application configured to connect to all 7 cache nodes, and one of the cache nodes failed, you notice that it's still trying to connect to that cache node. And so what ends up happening is your whole site slows down because one of your cache nodes, which was designed to make your site run faster, is dead. So you try to come up with these solutions where you look at the current active list of cache nodes and you reconfigure your application dynamically, and then when you come up with a situation that sort of kind of works. Announcing Amazon Elasticache. You want a memcache server? Tell it how many nodes you want. Boom, there it is. If a cache node fails, Amazon automatically replaces it immediately. You don't even know it's down. In fact, trying to figure out that it went down is hard. Because you just don't know. The only reason you can kind of sort of tell is because it being a memcache server, if one of the cache nodes fails, you lose some of your cache. So you notice that some of your cache is suddenly rebuilding. You're like, oh, the cache node must have failed. But otherwise, nothing. It still connects to it really fast because they just, swap that one out, stick it over here. So it's, again, brilliant solutions. And then there's search. I know certain people here, Elmer, love Apache Solr very, very much. I hate Solr. I hate Solr with passion. At one point, I had 9 M1XL Solr instances to shard my data set. It was very expensive. And you know what? It was still slow. I was still getting 4-second query times. And then, see, our data doesn't come in a trickle. We're not user-generated content. It doesn't like one article at a time. Our data would get dumped into Cloud Search as we would, pull up a new state code. So we'd get a new version of the Alabama state code, for example. And so we'd load 200,000 documents into Solr at once. And if you've ever dumped 200,000 documents into an active Solr that people are actually running search queries on, you probably know that search queries start to really, really slow down for about an hour while Solr schleps through that data. Solr was actually one situation where our solution was to give up. We eventually said, screw it. We can't make Solr perform to what we need it to do. We're just going to run Google search until we can come up with a better solution. So we just stick Google search on our site, and that's it. We use a Google CSE. And then Amazon says, wait, you really can run your own search, announcing Amazon Cloud Search. Cloud Search, no matter how hard I try, I can't make it perform slowly. I really can't. And I've tried. The only way you can sort of kind of get it to run slowly is to run insane queries that nobody would ever run. I mean, nobody. Like where you try to, Except me. Yeah, right. And even then, it was 3 seconds. Whereas the fastest I could ever get Solr was 4. I could run queries that's like this and this and this and this and this, not this, but this, and it would still 2.9 seconds. It's like, oh, that's so slow. Most of our queries run in 0.1 seconds. So, I mean, Amazon is so, Cloud Search it was fantastic. It was great. And if you load 50,000 documents into it, they do something where they'll just spin up another server temporarily, run all the indexing on that, leave your first one natively serving queries so that it's not touching it, and then they'll merge the data and shut down the extra server. And they do this automatically without you having to think. It did still have some limitations though. When it first launched, you didn't have a concept of field boosting, right? So you couldn't say that a match in the title is more important than a match in the body, right? So if you were searching for the word Google, you'd find everything that mentions Google, and the ones that mention Google the most would show up highest, and Google versus Viacom didn't show up so high, even though that's in the title. Obviously, so we start coming up with workarounds. We'll run 2 queries. We'll run one query where we're only querying against the title, and then we'll run one query where we're running against everything, and we'll put the ones where it's only in the title first. But now you're running 2 queries. It worked.
But 2 fast queries.
2 fast queries. So now but you're running 2 queries. Your cost is going up because every time somebody does a search, you're running 2 queries. Kind of trying to merge the data. If the matches in the title are also matches in the body, if you're just put one query on top of the other, you end up with the same results more than once. So you have to keep track of all the results of the title query and remove them from the results of the. Again, not a perfect solution. But that's okay. Amazon was listening. As soon as I get it working, build scalable search solutions with Amazon Cloud Search. This is much more recent. This is you see that this is March 25th and it has no year on it. That's because that was March 25th of this year. All the features that we actually missed of Solar. I didn't mention these, but Cloud Search also didn't have the concepts of per field stemming, where some fields you want to stem, some fields you didn't. It didn't have, like I said, didn't have field boosting. It only, in the first time, it only had 3 field types: text, literal, and integer. Unsigned and 32-bit integer, I might add. So your ability to do things like faceting by date or geographic search or anything like that was actually next to impossible. With this later announcement this year, they didn't just trickle in new features. They added every feature that was missing from Cloud Search in one fell swoop. They added everything that you could possibly want from Solar. In fact, they added so much stuff from Solar that you start working with you, it's like, did they just switch to Solar? And so you start reading their documentation. All right, and you get through your thing into, look, query parsers. Let's see how we can do with query parsers. What's this? You can specify to use the Lucene query parser. It is Solar, or at least Lucene. They have the features of local Lucene. They added lat-long fields, and you can actually do geographic searching natively in Cloud Search, and it's lightning fast. They added different query parsers. They added the ability to do per field boosting, where you can boost one field over another. They added the ability, basically everything you can imagine. And in the process, believe it or not, they actually made it faster. And I'm not just talking about the fact that I no longer have to do 2 queries. I'm talking the individual queries are faster, even if you add the field boosting to it, which normally slows things down. Now, I can't even get it to return in more than a second. No matter how hard I try, I have not found a query that takes longer than a second.
You tried dividing by 0.
Well, I haven't tried to do the impossible, so no. If you have headaches with Solar, or you just want to make sure that it always scales, I strongly recommend you give Cloud Search a try. It is fantastic, and it works really well, and you can throw almost any query at it you can imagine. So let me circle back to RDS and explain about some of its features that make it very Purple Squirrel-esque. Multi-AZ. So one of its core features you can just turn on, and you just check a little checkbox when you're creating your database servers called multi-AZ. Servers fail. They will fail. All servers will fail someday. If they haven't failed yet, then you're just lucky. Recovering from a failure of your master database server in the cloud is a pain in the butt. Multi-AZ, what happens is you check this box and they simply run two master servers with synchronous replication between them in different availability zones. In the event the availability zone you're actually using fails, they seamlessly transition everything over to the other hot backup master, and then they replace the dead node. We have not had an RDS instance fail since we launched it, or that we could tell. Schlepping back through the logs, I see it has actually happened a couple of times, but we never noticed it. So, if you run RDS and you haven't checked that box because you know it costs you a little more, it's worth it. Point-in-time restore. Dan mentioned that having a slave isn't, oh my god, I just dropped my database, I can't get it back solution. It really isn't, because that query to drop the database is probably already replicated down to your slave. But with RDS, they've got this feature built in where if you make a terrible query, you make a horrible mistake, you just simply have to know exactly what time it happened. And you can restore to any second in the last 30 days at any given time. Any given time. You can restore 2 seconds ago, although I imagine it would probably be difficult for you to run the query to restore it 2 seconds ago, 2 seconds after you've made your big mistake. Or you can restore to 30 days ago, and what it does is it simply takes it has up to the second backups constantly. Rolling 30-day backup. And at any given moment you can say, I want the way it was 4 hours, 32 minutes, and 16 seconds ago, and it will give you a new database server, because it's not just going to replace the one that you've been running, but it'll give you a new database server with the contents of your database exactly the way it was at that precise second. And then you can either take your stuff and put it back into your main one, restore it to your main one, or you can just flip it out and make that one your main one and kill the old one. This feature has saved our butts a couple of times. Drop tables and then mistyping the table name, or or running a truncate query on the wrong table, on your production table instead of on your. Oops, I ran that on the wrong server. This feature's great. I know that's never happened to any of you, right? Never. Automatic replication. If you want a new slave server, you just simply say, I want a new slave server. They can even do multi-level slave servers, because you can do slaves of slaves. So if you make a slave server, which they call a replica, maybe because they didn't want to call them slaves, and then you want to go a level deeper and actually have this treed structure where you're running queries all the way down here, you can make a slave of the slave, and you can go 4 levels deep. Presumably you could go further, but I've only tried it 4 levels deep. And at any given point, you can move one of those things up. Seamless hardware upgrades, especially if you're running multi-AZ. Because if you're running multi-AZ and you decide, this server can't handle the load, well, you just simply edit the server, change the server type, and what they do is they replace that hot backup slave with a new server type. So if you go from an M1 large to M1 XL, so your main is an M1 large, they replace the hot backup with an M1 XL, fail it over to that one, and then replace this one to an M1 XL. So from your user's perspective, a hardware upgrade of your database server is seamless and nobody notices it miss a beat. And Amazon takes care of maintenance of these servers for you, and software patches. They'll do the point upgrades for you, and the same thing. They'll do the upgrade on the hot backup, fail it over, then do the backup on the first one. So seamlessly, you just did that point upgrade, and you can even choose to do major upgrades. If you want to upgrade from 5.0 to 5.1 to 5.5 to 5.6, you can just do those. But of course, it does let you make the choice to do that, because that would break your application probably if it just did it automatically. Real quickly about the Elastic Load Balancer, I kind of covered this already. Really, really simple load balancing, multi-server redundant, I said all this. Actually cheaper, server monitoring built in, lightning fast, okay. Cloud search, I think I covered pretty much all this stuff too. Yeah, okay, skipping past it. All right, NFS. NFS sucks. NFS is always a single point of failure. You try to run an NFS server, if your NFS server fails, every server that was connected to that NFS server will then CPU hang. You replace it, and then you almost get to the point where the only choice you have is to relaunch every server under it. We had a point where we had an NFS server with 30 servers connected to it. And then Amazon sent one of those emails saying, this instance is scheduled for retirement. And you're like, oh, shoot. And then you spend the next 3 hours relaunching servers trying to get everything back up and running again. I have found a solution for this. Amazon doesn't have one. It's called Gluster. Gluster is an amazing little system. You can think of it as RAID for NFS servers. So rather than raiding a hard drive on a single server, you're raiding multiple servers. And if any one node fails, it just ports over any file access that's trying to go to that server to one of the other servers. I don't have time to explain how to set it up, but it's actually pretty easy, but replacing dead nodes is a pain in the butt and very manual. But that's okay. I fully expect, now that I have a system that works, I'll be getting an email any day now announcing Amazon blah, blah, blah. Our new multi-redundant shared file system, just mounted, it works just like NFS and everything will work and beautiful. So I expect that email any day now, at which point the hundreds of hours I spent trying to figure out Gluster and make it work, and it does work, and it works great. I'm sure that's going to be not necessary anymore. So, thank you guys. I don't have anything else.
So I guess it's a few minutes, so if anybody's got questions.
And in your cloud search thing, I saw quickly the solar plugins were mentioned. So you can drop in plugins similar to.
You can't drop in plugins. They have put a number of the most popular plugins in there.
Okay, so you can't.
You cannot.
A couple of our own.
You can't extend it, and you can't roll your own. You can't set up your own. Like one thing I had tried to do with Solar was set up my own tokenizer for citations, so that a citation was tokenized as a single thing rather than tokenized as 3 separate pieces of information. And so no, you can't do that. You kind of have to try. You do still have to work around that. Maybe they'll add custom tokenizers later, or
Amazon Cloud tokenizer.
I was like, maybe they will. I did mention to them that custom tokenizers would be a great feature. No, you can't load your own Solar plugins into it, but they've loaded a lot of the common ones, and they don't just load things willy-nilly because they care mostly about making it perform lightning fast. So everything they do load is heavily loaded in.
2 things. So, we had already kind of talked about RDS not having a shell. I'm assuming all those other services, no shell. You just get a basic.
Yes, that's correct. Now most of these services, they try to make it based on a standard. RDS runs MySQL, Oracle, or Postgres, your choice, and multiple varieties of versions. And you can access the MySQL shell or in the SQL shell, but you do not access the system shell. Same with Elasticache, same with Cloud Search. You don't have access to the physical machines because they're doing all the optimization and stuff like that. So they don't deal with that.
Okay. And the other thing, this is just kind of recent. I don't know if you read the article about Code Spaces having their Amazon credentials hijacked and then being held for ransom, and then the hacker basically nuking their AMIs, all their EBS storage, their snapshots, and now they have to basically shut down. Do you have any sort of doomsday scenario plan for that sort of thing? Because that's something that I'm trying to develop right now.
No, we are looking into, just for total disaster recovery, we're looking into spinning off our stuff also into Google's cloud. and even trying to look into doing some simultaneous stuff where we might load balance between the two clouds, so that if one cloud goes down, we can actually port everything over to the other cloud. Don't put your API tokens in your GitHub repositories. That's a bad idea.